Hi everyone, I'm Tsuchiya Kazuaki from the University of Tokyo, and I'm a member of the FIST project at RIN, Kyoto. Today I'm going to share our experiences in food system mapping and modeling team in the FIST project. My presentation title is Designing the Sustainable Foodshed of Japan: Insights from Ecological Footprint Modeling and Local Food System Mapping. And this is today's contents. Today I'm going to introduce 3 case studies, and before that I'm going to explain a little bit about the introduction. While the evidence for sustainable food consumption is increasing, but one for sustainable foodshed, where should food come from, is still limited. This figure shows current foodshed of Kyoto City, which means where does food come from to Kyoto. And in future, how should we change the foodshed for sustainability? So the goal of the FIST project, Food System Mapping and Modeling team, is to answer what should be done to achieve sustainable foodshed in Japan, and also to develop toolkits that can be applied in other regions. Today I'm going to introduce 3 case studies, and all in different spatial scales with different toolkits. The first study is about subnational ecological footprint modeling. In this study, our research question is about what makes the difference between the ecological footprint of prefectures in Japan. In the beginning, we have developed environmental extended MRI or model with downscaling method. We get ecological footprint of 47 prefectures of Japan. This figure shows ecological footprint of food sector per capita. The ecological footprint account the use of national resources with area indicator, global hectare, and in our analysis we have tried to understand the relationships with other socioeconomic indicators, and we found that the proportion of urban population and elderly population and also income per capita are significantly positively related to the amount of ecological footprint of food of 47 prefectures. And we also try to understand which sector occupies the largest part of the food footprint of Japan. And this figure shows land use categories breakdown of food footprint, and cropland and fishing ground were major land use categories in Japanese food footprint. And this figure shows subsectors of food consumption categories and its ecological footprint shares. And in Japan, food products, including fishery and wheat products, but excluding meat, accounted for more than half of the food footprint. So based on these results, we have concluded that sustainability strategy in Japan need to consider different decentralization and local food. Because urbanization increases, we found that urbanization increases food footprint, and by combining with depopulation trend in future in Japan, decentralization and the mixture of urban and agricultural land use is needed for less ecological footprint. And based on the findings in elderly people and food products, we assumed these results is because of traditional Japanese cuisine is depending on processed or imported food currently. And combining the population aging trend in Japan, we saw that Japan needs less processed foods and more fresh foods for reducing ecological footprint. And the need for fresh foods and also the decentralization of human habitats is closely related to the concept of local food. So we consider the decentralization and local food is needed for the sustainable foodshed strategy in Japan. Now let's move to the second study, local food self-sufficiency potential. In this study, we asked how food self-sufficiency potential differs between prefectures. This figure shows the boundaries and land use of 47 prefectures of Japan. And in our results, we found that the potential of local food self-sufficiency differs significantly among prefectures. Basically, prefectures in northern Japan have high potential of self-sufficiency, but major cities like Tokyo or Kansai area, including Kyoto, have smaller potential for self-sufficiency. We also asked how self-sufficiency potential differs between nutrients and scales. This figure shows boundaries and land uses of Kyoto Prefecture and Kyoto City scale. And this result is showing the self-sufficiency proportions for each nutrient at both prefecture and city levels. As this figure shows, the potential for self-sufficiency significantly varies between nutrients. And we also found that several nutrients like vitamin A, C, and K have higher self-sufficiency ratio at city level than prefecture level. So based on these results, we concluded that local food in Japan requires multi-scale thinking and increased production near cities. So every food system have multi-scale, multi-layered system. But for local food, the primary important scales are prefecture or provincial scales and city scales. And because the self-sufficiency of nutrients differs based on scales, we saw that multi-scale strategy for local food with balanced nutrition is needed. We also saw that the production near cities needed to be maintained or increased for ensuring and scaling local food potentials at city and prefecture levels. And the last study is about city-level food mapping. In this study, we asked, is the area of urban farmland decreasing under depopulation? And in results, we found that more than 10% agricultural land is lost in southern part of Kyoto City in the past 10 years during the depopulation period of Kyoto City. The black area is showing the lost agricultural land since 2007. And this figure shows the land use after agricultural land conversion. We found that 28% have been converted to vacant land. And in another study, we asked what hinders the use of farmers market among urban consumers. This figure shows the location of farmers market and supermarket in Kyoto city areas. Farmers market tend to locate more in peri-urban areas than in city center areas when compared to the supermarket distributions. And in Kyoto, we have conducted questionnaire to urban consumers about the frequency buying at farmers market. And based on the statistical modeling, we found that the distance to the nearest farmers market has a negative relationship with how often they buy at farmers market. And based on these results, we saw that special strategy linked with various actors is needed for local food. For each issue, agricultural loss and farmers market accessibility, special strategies such as zoning, land protection, or relocation to city center is needed. And these special strategies should be combined with various actors, including landowners, new entry farmers, or agriculture agtech startups, or stores, vacant land house owners, mobile vendors, food apps developers. So, in summary, throughout our research work in the food system mapping and modeling team in the FEAST project towards sustainable foodshed in Japan, we concluded sustainability strategy in Japan need to consider decentralization and local food, and local food requires multi-scale thinking and increased production near cities. And also a special strategy linked with various actors is needed for local food. These people are the members of food system mapping and modeling team in the FEAST project. And I would like to say thank you to all those people and thank you very much.